and thanks for joining. Uh, so today, like friends, we will be starting a new series of like DevOps tool, and that is a Docker itself. But we will be going with the advanced topic on Dockers, advanced Docker. So that's what we will be. We have started a new series now on advanced Docker. Okay, so now, I remember when I started recording this session, like we started with the Docker as a first, DevOps tools. We started recording at the same time last year, like in 2021, in the month of October only we had started it, and today again, like it is October month 2022, where we have come up and we are starting with a some more higher concepts on Docker, and that we will make it as an advanced Docker section. Under advanced Docker section, I'll be uploading all the videos actually. Okay, so here, like if you go through it actually, let me, if you see my channel actually, if you see my channel, you could see that if you go to the playlist, already we have a Docker actually. So we have covered around some 12 videos on Docker, right? So this Docker, like basically, this is a kind of an intermediate up to from the basic to the intermediate level with all the topics. Let it be a Docker networking, let it be Docker volume, Docker Swarm, Docker commands, how to deploy an application, how to write a Docker file. Everything we had covered in this 12 section actually. So this is kind of an intermediate. It means that from basic to intermediate we had covered here in this section, right? And this is a very useful. So I would request everyone to go through this. Go to this playlist actually. So you have to go through this playlist. So it is very important. And so this is the Docker playlist, right? So yeah, of course, there are few things are there which we had maybe we might have not explained in detail, or few of the things which got missed over here. That is what we would be covering in our advanced Docker topics. Okay, so there are many other things are there which we will be covering in the Docker advanced Docker, right? Let it be like how to check on uh, security level on the Docker, or how exactly Docker works in a cloud environment, like in AWS or in Azure or GCP, like how it works. So there are many other concepts are there which we would be covering in Docker. So this would be a pretty interesting, series what we would be covering. Okay, and that's what like. But the prerequisite that plus better first you go through this the earlier playlist what we had already covered, uh, right, in the last year itself we had covered, right? So that you go through this, that is very interesting. So we'll be learning more on the commands and everything. Now, as of now, I'll not be sharing any kind of a content what I will be covering the Docker, advanced Docker by today. Maybe by the next session, I will be showcasing like what are the things which we'll be covering in the advanced Docker section. Okay, and this advanced Docker, like how things happens means, like how you can get many more information through a Docker advanced Docker section is that you have to always go through the your official website actually. So Docker has an official website, that docs.docker.com. So this is a very important site where you have to go through, you have to visit the site where you will be getting across a lot of like advanced Docker concepts, as well as there are many articles are there in internet. Like I would be even sharing those articles which are the most important articles to be read actually by everyone. So we have to go through it. So I will be sharing those lists also later after some time. So which are the very important links and all, where we will be covering many of the advanced Docker topics, right? That links also I will be sharing with you. Okay, now, so today what we will do, like we will just start with the advanced Docker day one session actually. I don't want to really club this advanced Docker in my existing playlist, because we will create a separate playlist now, which we'll call it as a advanced Dockers, and there we will be uploading our videos as a day one session and day two session and all, right? So what we will do today, we will not exactly get into any kind of a in-depth concept of Docker now. What we will do, we will just go ahead with the quick recap of whatever we had learned on Docker actually. So today's session might be more on like revisiting the complete Docker concept once again, understanding how the Docker came into the picture and all, right? What is the history behind the Docker and how to install the Docker and how internally the Docker works, right? Those things and all we will be covering in today's part. Okay, fine. So those are the things which we'll be covering in today's discussion actually. Okay. So now, so before we start it actually, like let us recap on some of the quick information of the Docker actually, right? And before we start the Docker itself, okay, let us try to understand like how exactly the application development happens. So right, always whenever the developers develop the applications, they developed some kind of a project actually, right? They develop some kind of a project, right? So maybe like for example, if a developer is developing some e-commerce project, and they might have been using Java as a language to write the application, so they will use a Java as a language to write the e-commerce project actually. So you know very well that what exactly a software project is. Software project is nothing but is a software project. What is software projects? So software projects are nothing but it's a collection of programs actually. It's a collection of programs, right? It's a collection of programs. So you will have multiple programs together, integrated together, right? Right, integrated together. We call it as a software project actually. So and even like many of the software projects, right? Almost all software projects contains several components actually. What are the important components? Like for example, you take any project, right? You'll be having something known as a front end components. You'll be having something known as a back end component. So front end is nothing but you are basically your like UI, your user interface component, we say, right? And the back end component is nothing but you are basically your core business logic, right? Your core business logic is nothing but your back end component, as well as you will have something like a database component. So you take any of the projects actually, majorly these projects have these three different components actually. There are many other components are there, but majorly these are three components which you will find actually. Okay. Now, whenever the developers are developing the project, right, they will develop all these three components, or they need all these three components actually. Okay. So if you understand through the diagram format, right? Now, basically what happened, right? They will be developing some components, like for example, in the backend component, they'll be developing some kind of a component which they call it as a web component, web components. Okay. And they will be developing some other components which they call it as a business component. And they will be developing few other components which they call it as a persistence component actually. Components. So these are the three different components which they will be designing actually, which they will be developing like this. Right. Of course, persistent component is a component which actually communicates with the database. So this we call it as a backend, your backend of your project, right? So whatever we told, right, there are three components: front end, back end, component, database. So this is not what your back end component. The back end component compromise with all these three: web component, business component, and persistent component, right? And what you do basically, so you will be using some kind of a language or the program, right, for developing this backend. Like for example, you would be using something like a Java uh, 1.8 version for developing this, right? or else you will be using some Spring Boot 2.x version, or else you will be using some kind of an Hibernate 5.6 version, or else you will be using some PHP, right? Or you might be using some Ruby, or might be using some Python. So you can use any kind of a language to develop your backend component of your project, right? So after this, what happened, right? You basically, whenever you want to store any kind of your application data, you would be storing all your data into a database, right? So basically, you'll have one database component here like this. So this is nothing but your database actually. So your backend component basically it always communicates with your database like this. So this database, right? This database might be Oracle database, Oracle 12, or else it could be a MySQL, or it could be any kind of other DBs, right? So it could be or it could be MariaDB. Any DB might be. So you would be choosing any one of the DB to store all your application data into the database actually, right? So after this, what happened, right? You would be having one more component which we call it as a front end component or nothing but your user interface component. So this is nothing but your user interface component actually. We call it as a UI. So this UI is not but the front end component, right? Like for example, whatever the browser, if you open any site, right? Whatever when you open the site through a browser, right? Whatever you see the web, right? The web page, right? That would be like the front end component actually, right? It is nothing but the front end component. And this front end component basically, they users how you develop a UI or the front end. Basically, you use some HTML templates or see what is it CSS templates use, or you can even use a bootstrap or javascript or any kind of a like front end component. You use a jQuery, right? Or else your angular js or react something we say, right? React js. So you use any of this tool or is any of this language to develop your front end UI. We call it UI, or we call this as a front end actually. You call this as a front end component, right? And always your front end component, you know that it always communicates with your backend, basically, right? It always communicates with your backend. So right. So now what happened, right? Like whenever a developer is developing, what the developer will do, he has to before he starts it actually he has to install all the softwares. He need to create an environment where he can start writing, or he when he starts writing a code, or when he starts developing the code, right? So he has to install all the softwares, required software versions, whatever the particular version. Suppose the developer is developing this whole e-commerce project in Java 1.8. He has to install the Java 1.8. Suppose he's using the Windows as an operating system in his machine or in his laptop, right? Or in his system. He has to install all the softwares, right? He need to install the Spring Boot, Java, everything. He need to basically have a like a kind of a web framework he need to have, where he can start writing a code, and he will develop the complete code, right? The whole project code he will develop it, right? So that's what the developer does it actually, right? Now what happened, right? After the developer writes the whole code and all, what the developer will do, basically the developer is going to keep all this development code under any kind of one of the repository, right? Source code repository or source code version repository, which we call a git or git repo, right? So what the developer will do, basically the developer will, so let me open more MS Paint. So what the developer will do here, once the developer develops the complete code, so he's a developer. So once the developer writes a complete code, what he'll do that he will put the whole code into some kind of a repository. So basically he will choose a Git repository or Git repo. So he will push all the code into the Git repo. correct? Now, what happened, right? Once he develops all the code, so what does the developer can share the complete code to the client, or does he has to do many other operations? Like for example, once the developer writes a whole code, right, he need to first verify or test it basically, right? He need to verify, test it. Also, he need to set up an environment, basically something like a dev environment or dev setup. He has to do it actually. So we have a, so during software development life cycle, right, when we develop the product, actually, basically we have to undergo many of the different testing phases, so that to make sure that your code perfectly works. So whatever the functionality or whatever the function which you have implemented in your product, right, or in your software product, that has to behave properly, it has to work properly. So that's the reason what happened, the whole the software, right, it undergoes some kind of a testing actually. So for doing a testing, what happened, right, you need to have a lot of different environments basically. So what are the different environments you have? Right here you have something like a dev environment. So we have a dev environment. Similarly, like that, what we'll have, that we'll have a many other environments. Like for example, you have a dev environment, you have a like a site environment, you have some other environments like UAT environment, UAT environment, right? Similarly, you have some more other environments, some few more environments, like we have a pilot environment, and finally we have a prod environment. We have a prod environment. So these are the different environments where like the software has to be tested, and finally the software, the whole product of the software has to be pushed into the production mode finally. So this we call as a live environment, right? We call it as a live environment, right? So now what happened, right? Whatever the software product which is developed by the developer, he will push all the code into the Git repository. And what exactly has to be done later, this software product, whatever it has been there in the Git repo, this has to be finally, it has to get deployed here. This application has to deploy into this various different environments. And who will deploy the code into various different environments? It is a DevOps engineer who does that actually. So we have a DevOps engineer here. So what the DevOps will do, DevOps guy will do, he will take the code which is in the Git repo, and he has to deploy under his different environment, right? So so now the thing is that actually that each and every, so whatever the environment which you had developed, suppose like this application, whatever the application which you have written, right, it needs a particular environment actually, or it needs a particular set of softwares, so that the your like your project will get executed. So what happened, right, basically you need some kind of environment, like you need some kind of a software. So what you will do, basically you have to install the software stack, we say. Like uh, for example, in case of all this environment, right, you need to have something like you need to install the Linux operating system, plus you need to install the Java, that is 1.8 version, plus you need a spring boot, plus you need some kind of a database, right? So all this, right, these are the software stack which we need along the operating system. So what happened, that you need to install all these softwares in all these environments actually, right? So one of the task of the DevOps is to set up the whole environment stack or the software stack in each and every environment, so that this application can run in the under this all these different environments, right? Like for example, the same stuff actually you need to even have here, even in your SIT environment, even in your UAT environment, even in your pilot environment, as well as even in your production environment. So you need this complete software stack actually, right? And it's not only with the Java actually. See, you cannot execute or you cannot run the whole project only with the Java. You need many other softwares, right? So Java is one of the software stack which is required. Apart from that, there are many other software required, right? Many of the libraries, many of the binaries are required for running your whole project. So Java is not only the code. Java is not the only software. So you need many other, like you need a Spring Boot, you might need a MySQL, you might need a Big Data or Hadoop or Hive. There are many other softwares are there which are required for your project to get executed, right? So who does all this setting up of all this different environments and installation of different softwares and everything to this environment? It has been taken care of with DevOps engineer actually, right? So now the what is the challenging task basically? So this is what it is. This is why earlier, like when the DevOps engineer was working, right? So what was the difficult task, or what was the challenging task which the developer was facing? That so deploying an application to this multiple environment was a challenging for the DevOps engineer. So what was the challenging task? Deploying the application into this into the multiple environment. So that was a challenging task. So in order to deploy this application into the servers or into this machine, we need to set up all the software which is required for our application. Like for example, we need a operating system like Linux, we need a Java, we need a Spring Boot, MySQL, Tomcat web server, etc. Anything, right? That is what the challenging task. Now the point here is that actually that we need to have a same version or the same software to be present in all these different environments, or all into this different servers or into this machine actually. Now the thing is that actually, right? For example, suppose assume that actually your dev environments has already it has some kind of a Java 11, right? Your U8 environment has something like Java maybe like 1.3 or 13 or whatever, 13, or else your production might have Java 1.5. Now the challenge is that actually that so if you are having some different configuration in these different environments, whether your application software will work in these different environments, so it might not work, it might fail actually, right? Because of the mismatch of the software versions, whatever it is there, right, in these different environments, so it might not work actually. So the challenging task for always a DevOps engineer is to make sure that whatever the software version which that application code requires or the project requires to be executed, that particular version need to get installed it actually. If already there is some other version is there, and if he's deploying the code, suppose like in SIT, assume that it is having 1.2 Java version. I'm just taking some example, Java 1.2, and he has already deployed the DevOps engineer has already deployed the code into this SIT environment. Maybe that code might not work because that code has been developed in 1.8, and whatever the existing environment which is already there in SIT environment is 1.2. So your code might fail or your project might fail. It might not run actually. So this is what the challenging task which the earlier like the DevOps engineer was facing actually. So that's the reason what happened. This is the main reason why like we are getting into the Docker or we are getting into the containerization actually. Okay, now what we'll do, like, let me write the note whatever I have explained it, let me write in a note now. Okay, so in order to deploy our application or whatever the project what we have designed, right, the e-commerce project, right, in a machine, we need to set up all the softwares which are required which are required in order to deploy our application project in a machine. We need to set up all the software which are required to our application to our application. Example, like like we need an operating system that is a Linux or Unix, right? And we need a Java 1.8. We need a MySQL DB or any DB which you have. You'll need a Tomcat web server, something like 9.0 version, like etc. Any kind of software you need, right? So so that's what we need to deploy our application. So we need to have a setup actually, right? So that is a challenging task, right? And because we have to do all these things in all these three on all these different environments, right? So basically what happened, right? In real time or in real time project actually, in real time project, in real time, uh, in real time what happened, right? The project should be deployed into multiple environments, like whatever we have, right? The multiple environments like dev environment, SIT, UAT, right? These are the multiple environments for testing purpose actually, right? See, whenever the code is been developed, you cannot directly push that code. You cannot simply take the code and push into the production. You cannot do that actually, right? Because your product might not be stable, or whatever the code might have been there, that might be having a lot of bugs. You cannot directly push the code into the production. That is that nobody does it actually, right? So because you have to undergo a lot of testing, so that's the reason what happened, right? Initially what happened, once the code is developed, so what the developer will do the testing of the product into the dev environment here. So so dev environment will be used for the developer to perform the integration testing, we say. So once the integration testing is completed, what happened, right? What the DevOps engineer will do, he will try to deploy the same code into the SIT environment. So SIT, we call it the system integration testing. Okay. So this is basically a test environment, we say actually. So this basically the SIT environment, what the tester will do, the tester will do a functionality of the application. He will test the functionality of the application. He will test the product. He does some lot of other different regression testing, stress testing, everything he will do to make sure that actually at any point of time your software doesn't break actually. It will work at any condition. That's what the SIT engineer or the testing engineer will do, right? And after that, what happened that you have one more one was a UAT environment. Basically, UAT environment is used by the client to to test the functionality of your application. So UAT is a user acceptance testing, we say, right? UAT acceptance testing is not user acceptance testing. This is the environment where the client will do the test of the functionality of the application, right? After that, what happened, right? You have one more one was a pilot environment. Pilot environment is nothing but the pre-prod environment or the pre-production testing environment. So before the code is pushed to the actual production server, they will do some kind of a testing in the pre-prod environment, which calls a pilot environment. And finally, what happened, right? Once the application undergoes various different phases, right? Testing phases. Finally, we certify that the product is stable, it works stably without any issues. Then the whole project, right? It will be deployed, the whole software or the product will be deployed to the production environment or will nothing but the live environment, so that the whole project will be available to the outside world, or it could be available to any kind of end client user, right? That's the reason we push the code into the production. So production environment means that environment it is used to deliver the project here actually, right? So let us write whatever I said now. So in the real time, project should be deployed in a multi environment for the testing purpose. So that's the reason we have a different environments. Like for example, we have a dev environment. So it is used by the developer to perform integration testing. And then you have a SIT environment is nothing but the system integration test, system integration testing. So basically, this environment it is used by the testers actually, testers or testing team. You can say it is used by the testing team to test the functioning of the application. and we have something as a UAT environment. Next, right? User acceptance testing. User acceptance testing. So this environment it is used by the client to test the uh, functioning of the application, and we have a pilot environment. A pilot environment means it's a pre-production testing environment. Okay. The last is nothing but your uh, production environment. Prod environment, which we call the live. Okay. It is used to deliver the project actually. That means the whole application at the end it would be deployed into your production environment. Okay. So now, so as I said earlier, the challenging task for the DevOps engineer is to deploy this application into this various different environment. That was a very challenging task, and like uh, like many times what happened, right? Because of some software mismatches, the product was not able to run comfortably in this environment. So that's the reason what happened, right? We came across with this Docker concept actually, right? So we came across with the Docker concept. Even what happened, right? Because of this uh, the whole application stack, right? Set up in the whole application stack, right? We have many of these components like front end components or back end components or DB or environment like libraries or dependencies. We call this completely as a software stack actually. We call this completely as a software stack actually. So basically, the software stack it has to get installed into various machines. Basically, it has to get installed in your computer or it has to installed in your laptop. It has to get installed your in your in your PAM top, or it has to install in various different other environments, right? So there is no guarantee that your application will work because to for the application to get executed, right, it needs a particular software and its version to be deployed, to be installed, right? So you have to always make sure that actually that particular version, like for example, your application is developed in the Java 1.8. So always Java 1.8 should be there actually. Maybe like it might support with the Java 1.8 or greater than the 1.8. But if there is already, if some other software is already installed which is lesser than 1.8, right, and you are deploying your application, right, maybe your application might not work, it might fail actually, right? So suppose for example you take this whole project, right, you take it and you go and you install it in your Mac OS, right? And or else some other person will take this whole project and he will go and install in the Windows, right? So maybe the customer, the client, right, he might use this project in various different operating system also. He might install it in Mac OS or he might install it in Windows, right? You have developed this application in the 1.8. Maybe the client might have installed the Java 11 installed in his servers, right? In his location, right? So there are a lot of mismatches are there actually. That's the reason you would have seen even that even when the developers, right, when they develop the code, so one of the developer he said that okay man, I have installed the code in my machine, but it is not working actually. But whereas the same other developer will say the stuff that actually I have installed this code, but it is working in my in my system. So you might have come across with various stuff, right? People talk like that. Some that same application might work in one server and it might not work in other servers, right? So the possibility is that actually because of the mismatch of the softwares, or there could be some kind of a missing of some dependencies or libraries might be missing. There are various reasons are there. That's the reason what happened. Your whole project or the software code might not work actually. It needs a stable environment to run actually. So that's the reason what happened. That DevOps engineer plays a very vital role to make sure the whole setup of the software should be installed before your project get deployed actually, or before your application will get deployed actually. But again, for the DevOps, it is a challenging task that he has to deploy the same application into various different environments. He has to manage all these different environments, and he has to make sure that there has to be a stable version of software should always be present. If there is some other software is installed, then it is a nightmare for him. He has to crack out, he has to think, he has to triage the issue, like why exactly the application is not working right. So there are many issues where the DevOps also faces actually on a day-to-day activity. So that's the reason what happened, right? This was the reason what happened, right? The Docker came into the picture actually. So guys, I hope that you are understanding whatever I'm trying to tell here, right? So, but so what earlier it used to happen? Earlier, what happened? How exactly these different environments were getting created actually? So forget about the Docker now. Like if you go back in a long time, like 10 years back, if you go back, right, how things were happening. So basically, what happened, right? You need to have a VM. You need to have a VM. Means that you have a VM actually, like this. You have a physical machine, like you will have a VM of the physical machine, right? So this is nothing but your physical server. So basically, I'm talking about here about the virtualization concept actually. So I'm just talking about the virtualization concept here. Okay. So when what virtualization, what happened at basically like we have a VMware, we have a physical machine. So they call this as a physical machine. So I'm just trying to tell that how exactly these different environments are set up now. Earlier, how it is to get set up? It is to get set up with the different with the help of a virtualization concept. We used to create a virtual VMs, and through the virtual VM, we used to have all these different environments like dev environment or SIT or UAT, right? We used to have that actually. So here, what happened, right? We used to have physical machine. Physical machine was there. On top of the physical machine, what we used to do, right? We used to install an operating system. We used to install the operating system. It could be Linux or Windows or anything. Linux or Windows. Any operating system is to install it actually. Preferably Linux we used to install, right? And on top of this operating system, what we used to do, right? We used to install the hypervisor actually. We used to install the hypervisor. So the hypervisor software, it could be something like a VMware, or it could be some Hyper-V of your Microsoft, or it could be a KVM, right? Or it could be a Zen, like any software, a virtualized software, right? You you were able to install it actually. So this we call the hypervisor actually. So on top of this hypervisor, what we used to do, right? We used to create a VMs actually like this. We used to create a VMs like this, right? So this is not, but this is the virtualized OS we used to create actually. So this we call it as a host operating system. We call it as a host operating system, right? And here what happened, right? We used to create a virtual VMs. So each and every virtual VMs, right, will have its own guest operating system. We call this as a, this is also an operating system only. This is also an operating system, but this is also operating system, or I'll just call it as a OS actually, operating system. But we used to call this as a guest operating system. This is not but the guest operating system, guest OS. Okay. So we used to have a guest OS. We used to have some dependencies, application dependencies like there's our libraries. We used to have application dependency and libraries, right? Uh, how is it? Like we used to have a application dependencies, dependency files or libs libraries. So all the application, all your application dependencies or libraries which is required, right, for application to run, right? That we used to have it actually, and then like here on top of it, we used to install your application like this. Just to install the application like this, we used to install our application. We used to have the application like something like a app A. application A, something like that. So this, the whole we call it as a VM actually. So this is something like a VM actually, virtual machine one. Right. Similarly, we used to have the same thing like virtual machine two. We used to have like this VM2, virtual machine two, virtual machine three. Right. So what earlier the engineers to do, right? They used to have in a single server with the help of a hypervisor, they used to create a different VMs, and each and every VM had its own operating system actually, had its own operating system, which they call the guest operating system, right? So within this VM, what happened, right? What the engineers to do, right? They used to set up the whole stack. So they used to install the operating system, that is Linux. They used to install the Java 1.8. They used to install the Spring Boot. They used to install the MySQL. All those softwares or all the software which is required for your application to get executed, right? That everything which to get installed in this VM actually. We call it a virtual machine, right? And so this is a virtual machine, right? So your application should get executed actually, right? So this the whole thing we call as a virtualization. So it means that what do you mean by virtualization means within a single machine, with a single machine or within a single server, we have a operating system and we install the hypervisor so that we can have a multiple operating system, many more operating system. You can install it with an existing operating single operating system or the single server, which we call it as a virtualization actually. So this is a very basic concept actually, right? So this is a very basic concept actually of virtualization. So yes, virtualization has some advantages, it has some disadvantages also. Like if you take, if suppose if they ask in an interview what are the advantages, like what are the advantage of uh, virtualization VM. Virtualization means you have to say, like for example, you can have a multiple OS in the same machine. That is what the advantage. Second advantage, something like you can say that it is very easy maintenance and easy recovery actually. And we have a lower total cost of ownership actually. So before this, right, whenever you used to deploy it before the virtualization, right, for each and every single application deployment, right, you used to have a single server. So the cost effective was more there actually, because you need to procure a lot of servers to run application. So later what happened is once the virtualization concept came to the once the virtualization was designed where we can have an hypervisor, through a help of a hypervisor we can have a we can we can create a multiple host or we can deploy multiple virtual machines, right? Within the virtual machines you can have the software stack like operating system, application software dependencies. Finally you can deploy the application where your application can get executed by that particular virtual machine, right? So that is what it was very easy, right? It becomes very simple or very easily to deploy the application or create a different environments. Like you can create an asset environment, you can create a dev environment, you can create a pilot environment, like that with the help of a different VMs we used to create it actually, right? So these are the advantages. What are the disadvantages actually? Disadvantage of the virtualization. Disadvantages. So the first point is that multiple VMs leads to unstable performance actually. See, because you have a multiple operating system, right? Right. When it comes to a performance, it might not perform because like each and every virtual machine, again, it will be given a set of hardware resources with an existing physical machine itself. So what happened, right? If your host operating system becomes slow, actually, if it is not performing very well, even your guest operating virtualization will slow down. It will not work properly. So it leads to a unstable performance. You say, okay. So hypervisors are not as efficient. Actually, we say not as efficient as your host operating system. That's what. So, what are these guest operating system or the hypervisor, right? They might not be as efficient as how your exact host operating system works actually. So, host operating system has a full-fledged usage of the complete physical resources, whatever it is provided by the system, right? The same might not be for the guest operating. That's what hypervisors are not as efficient as operating system. So you might see some performance degradation when it comes to the virtualization and long boot up time actually. Long boot up time or long boot process is to happen for any kind of a VM. So like approximately sometime it used to take around 2 minutes or 1 minute, around 1 minute to come up with this virtual machine. Suppose you switch on the virtual machine, it might take around 1 minute to come up. So it takes some long duration, some long time to come up actually. So those are some of the disadvantages what we have in virtualization technology, right? So because of this, because of this virtualization technology, right? This is one of the mechanism where the people used to deploy like or deploy or create a different environments into these VMs actually, right? So but as I said, right, virtualization is a very old concept actually, right? It's a very old concept because the size is very big here, right? So here you are even allocating most of the memory spaces even for your operating system itself actually. Okay, startup was very much it is to take some long time to get started up, right? And the integration of the application was also very difficult here. So that was also one of the challenging tasks actually, right? So to overcome these disadvantages only we came up with the concept of the containerization actually. We came up with the concept of containerization. Now in the containerization, what happened, right? The same stuff actually. So what happened, right? So this is nothing but your virtual machine or your virtualization or VMs you can say, vm or virtualization. Now, the same thing, what how it happens in a container or more specifically as a Docker container, if I talk about, like I will draw it here in the same slide so that I need not to go to the some other like one more MS point I need not to go. Like you will have something like a physical machine, same thing. So I'll have a physical machine here. So on top of the physical machine, we used to install the operating system. You know this very well that now you used to have an operating system. It could be Linux or Windows or any Mac OS or anything. So, but more specifically, we will be installing the Linux machine itself, Linux. Right? And on top of this operating system, right? What we used to do now, we used to bifurcate from the hypervisor. It means that we didn't install the hypervisor. Instead, what happened that we used to install the Docker actually. So once you install the Docker software, right? What happened, right? You will get a Docker engine here. You get a Docker engine. You will get a Docker engine. Now with this Docker engine, you can create containers actually. You can create a container. So like this. So we will be revisiting that what is a container, what is a Docker. I might be I'm using a lot of terminologies, but yes, we will come across with that actually. We used to create a lot of containers like this actually. So whenever you want to deploy any application or whenever you want to run any application, we can run an application into a container. So this container will have an application, like suppose like some same thing like application A and the dependencies actually. The dependencies, files or libraries, whatever the libraries or files it requires, right? That used to have within this container. This we call it as a container. This we call as a container. Okay. So like that, even like that, we used to have a multiple containers actually. So here in this container, we used to have an application known as the app B, which is to run, and it has the same thing. It has the dependencies and dependency files and the libraries. So similarly, you will have one more container like app C, right? So because of this virtualization being very old technique actually, So later what happened, right? We came across with something like a container technology where they developed, particularly the Docker community, right? They developed in such a way that actually that you can create a container. So here what happened, right? You have a base, the operating system is same actually. The operating system, base operating system or the host operating system is same. But what happened, right? On top of it, we used to install one uh, Docker software. Once we install a Docker software, right? Basically, we will get a Docker daemon, or we call it a Docker engine actually. So this Docker a daemon or with a Docker engine, right? We can create a container actually. So with that container, we can run an application. So this we call it as a Docker containers actually, right? So what is a Docker, how the Docker came into existence, like those things we will discuss later. But what happened right now, what I'm trying to tell that here, we don't have a separate OS for each and every thing, right? The base operating system itself will be used. Of course there are some features of the base operating system is there which will be used by the Docker engine itself to perform it actually. But ultimately what happened, right, for each and every container we don't have a separate guest OS as what we used to have in virtualization. So what happened, right? We are more concentrating on the application and its dependencies. Here, what happened, right? Along with the application, even you need to even have a guest operating system also. So there, what happened, right? A lot of memory is to get used by each and every operating system within the VM also. And here, there's a no resource constraint will be there because each and every VM will have a particular set of resources. So he might get a particular CPU, cores. He might get a particular RAM memory. He's to get a particular scheduling time, right? Or the processor time, right? So he's to get a particular size of the disk space for him, right? So there, what happened? The resources was constrained for each and every VM. So he cannot use more than whatever it is assigned the hardware resource for each and every VM. Whereas here, what happened, right? There is nothing like as such because here, what happened, right? Since you are you are deploying an application, the application what it needs more, it needs an environment first. What are the environment? What are the software environment it needs? That it requires, plus it needs all kind of dependencies. Only those things are the things which are required. So here what happened in case of a containerization, the importance is given for the application and its dependency, not for the operating system. So that's the reason what happened, right? You can create as many number of containers as you need. Suppose tomorrow you say that Rajesh, I need some 100 containers. Yes, you can create 100 containers. But the same way, here you say that in the same setup, you say Rajesh, I want to have 100 VM. You cannot have 100 VM because we don't have that much of physical resources. We might not have that much of CPU, we might not have that much of RAM or hard disk, right, to create 100 VMs because there's a limitation because of the physical machine limitations. Even we have a limitation with the creation of the virtual VM also. Whereas here there is no constraint as such. You can create as number of containers as you need actually. It's all depend upon whatever the lower machine physical memory resources are available, right? Based on that, you can create as number of containers as you need. That is what the advantage which comes in the container technology, right? So 1 second, guys, I'm getting a call. Okay, sorry. So yeah. So what is an advantage actually? What is the advantage of having a container? So what is the advantages of or advantages over virtualization? You can say over virtualization. Like so containers on same OS kernel are lighter and smaller, we say, right? So always this contains whatever the contains, these are very lightweight containers actually. And these are smaller actually, right? That's what. And the second point is that actually we call it as a better resource utilization compared to VMs actually. And the third point is that actually short boot up time. Here, what happened, right? In the disadvantage of VM, that it needs a long boot up time, short boot up time. So whenever you want to make your application up, right, it used to just take something like 1/20th the second of the second to make your application come up actually. So it is so fast that you can, you can make your application very fast available, right? So that's what you call the short boot up time. So that's what you see that nowadays most of the industries, right, they are getting into the containerization rather than getting into the rather getting into the your into the VM, right, virtualization, right. They are more interested into get into the containerization. Somehow your application behaves very fastly when you are deploying all your application in the container world actually. And the famous container is nothing but your Docker containers. So that's what like what happened, right? We need to get into the Docker container. So whatever the issues where the earlier the DevOps engineer used to face, right? So have set up of the whole environments, everything. Now it has become a very easy for the DevOps engineer, because all those applications, whatever the developers is developing, right? He is developing under the Docker container. So he will keep in a mind that yeah, my application, whatever I am developing, so the developer is developing some e-commerce application, so he will make sure that that applications compliance with the container technology, as well as what happened, the application will get deployed or hosted into the container, and it successfully runs in a container. That's what the developer does it actually, right? So so what is our journey is that actually now like we'll be learning like what exactly a Docker means, right? What exactly a Docker means. So just a second, guys, let me have water. Oh, okay. So that's what Docker came into the picture, right? So what is a Docker? So we say that Docker is nothing but it's a platform for packaging, deploying, and running your application, right? So here, as I said earlier, right, whenever you want to run your application, you need to have so many different requirements for your application to get run. So basically, it needs an operating system, it needs a Java 1.8, it needs a Spring Boot, as well as it need a MySQL, right? So so there is a software dependency is already there. It means that you need to have a software dependency to run. So now what happened, right? And also it needs a kind of a, suppose like you are working or you have deployed, you have designed the application to get executed, right, only on some few operating system like on Windows or on Linux, or else in some other Mac OS, right? Now what happened, right? Basically, there might be a chance where happened, right? In your you might be hosting your application into the Windows server. So that Windows server might have a different setup altogether, right? It might have a different Java, it might have a different Spring Boot. So whatever the dependencies required for the application, right, the version might be different, or it might have some other dependencies which are already installed, so your application might not run properly there, or it might not run at all. So that's the reason what happened, right? You will have a Docker container actually. So with the help of a Docker container, right, what you can do, right, you can actually package, so that you can package all its dependencies. Means that the Docker needs suppose like the Docker the application needs Java and Spring Boot and MySQL to run. So you can have all these things as a single packed in a container actually. It means that in a single container you can have the complete software dependency, so that your application, the main application, can get executed within your Docker, right? So that's what we call it. Docker is a platform for packaging, packaging, deploying, and running the applications. Running the applications. So Docker uh, enables you to separate your application from your infrastructure. So so that you can uh, deliver the softwares very quickly. Okay, so it separates it actually from infra so that you can deliver it. So here what happened, right? You're not really like you're not the containers, right? That doesn't really require the it doesn't really require much attention with an operating system actually, right? It only needs a dependencies, right? It needs only the software which it requires to run. So those softwares, everything you have bundled everything as a package actually, and you have deployed and you have made it to run as a container. So that's what Docker helps in doing all those things. It helps in packaging, deploying, as well as making your application into a running state, right? That's what container comes or Docker contains comes into the picture actually, right? So what is the other thing? So Docker packages, we say that Docker packages software. We say Docker packages softwares into a standardized units called containers. Okay, that have everything the software needs to run, including the how I can say, including the dependencies, libraries, system tools, your code, and even some kind of a runtime like that. So Docker package, it means that whatever I said earlier, like whatever you need to run your application into the container means it needs all kind of a softwares. It needs dependency, libraries, system tools, code, everything, right? You bundle, you package it, everything, and then you run it into a container. That's what the Docker helps to do all these things actually. Okay. So uh, what else? By taking the advantage of Docker methodologies actually. So these are all the methodologies. What by taking the Docker right? Methodologies for shipping or for testing and deploying the code quickly. You can actually significantly support actually or reduce the delay between writing the code and running in the production actually. So earlier what happened, right? See, the problem is that with the virtualization is that actually, right, you need to create a VMs actually. You need to create a VMs and you need to deploy, you need to install all the operating system and dependencies and everything. Finally, you need to test it. Once you test it, you need to have a different environments testing, like SIT environment, right? Or else like UAT environment prior to node. So what happened? So there has to get some kind of a delay you can see while while running your code, everything finally into the production actually. So is to see that there could be some kind of a delay if you are with the virtualization technology. Now what happened because of this Dockerization technology? What happened, right? It has made the life easy, right? So it has made the life easy for the testing purpose. It has made the life easy for the shipping, as well as it has made the life easy even for the deploying of your code also, because everything comes as a package here for running in within a container. So it has really reduced the gap of writing the code by the developer and finally delivering that code into the production or finally deploying to the code to the production environment. So that's what you could see that whenever the companies or the developers who use the container technology, right? So you could see that the release times are very faster there because what happened, right? They will release the product very faster to the customer because they're using the container technology because it will reduce the gap actually. It will reduce a lot of dependencies and everything, and significantly it will reduce the delay between everything, right? Whatever the delay is to see in the virtualization, right? That get reduced when it comes to the containers actually. So that's the reason you could see most of the industries now, almost all the industries now, they are getting into the Dockerization technology or they're getting into a Docker containerization. Okay. Okay, guys. Fine. Now, what else is there? So, what we return? So that's the reason what happened, right? Because right there is no dependency of no installing any softwares and all, or having the common vision software, right? So that's the reason you could see that if you have developed in a container, and if the container works in one single machine, right? Suppose you are having a Windows where you have installed the Docker and softwares. Through the Docker, you get a Docker Docker daemon or the Docker host you get, right? And you can run that application or the software into your Windows where the Docker is already installed. So what happened, right? The container will start running and it works actually. If your container works in any one of the environment or any one of the operating system, you'll almost will you'll make sure that that application even will work in a multiple different environments or into multiple different platforms. Suppose I take the same container, right? Same container instance, like you need to have an image. Actually, we have not yet come across with what is the image and all. So there are something the terminologies will come across something like a, I might you might have already know this all this thing, but I'm just saying we come across something as a Docker images, or sometime we'll come across the Docker file, right? So these are some of the terminologies we'll come across. So we will be coming across with these terminologies later. We'll be using heavily what is this Docker image and everything. So basically, whenever you want to deploy any application, right? Whenever you want to deploy any application and you want to run as a container, you need to have a Docker image actually. So with the help of a Docker image itself, a container would get created actually. Containers are getting created if you have a Docker image. So to have a Docker image, you have to develop a Docker image with the help of a Docker file. So Docker file is a method where you create a Docker image. With a Docker image, you finally create a container, a running container. Means you have image, you need to create a container, means you have to run that image within a container, we say actually. Okay. So in next class, what we'll be doing, right? We'll be going in detail about what is this Docker image is all about, what is a Docker file, what are the different components we have in the Docker file, right? And also what are the different Docker commands which we'll be using to write a Docker file. So that is what we will be starting in the next session actually, right? Right now I will not be going in detail about all these things, right? So okay, so what I said that if you are making your container run in any one environment, like suppose if I run, if there are several developers are there, if one developer say that yeah this container is running in my machine, right? Because I have Docker installed and this application is running in the container, it is successfully running. You can 100% guarantee that the same application with the container, right? It will even work in other machine also. So that's the reason what happened, right? If there are 10 developers are there, and if the 10 developers are having a different machines with them, one person might be having Linux installed in his laptop, and other developer might have installed Windows, and some other third developer might have a MacBook actually with him. He can make run the same application in all these different machines. So that's the reason you could see that all the developers will say the same thing. Yeah, the code is running in my machine. Even the other developer will also say that yeah, the code is running in my machine. Earlier, what happened is because of this virtualization concept, because of the the software stack has to be there right before running application. Because of mismatches, the developer themselves used to say together, right? Just to say within them that okay, this software is not working in my machine, man. But how come the same software is working in your machine, or the same application how it is working in your machine? They used to have a discussion. So earlier, what happened, right? Long back, what used to happen, right? You used to have a different configurations, different setup in each and every laptop. So sometime the what happened, right? Their application will run in your laptop. The same application might not run in your other developer's laptop because of the because of the mismatch of the software configurations and the hardware configuration, and many other dependencies files are there, right? Because of that, it is to never work. Now what happened, right? Now each and every developer can say easily that yes, mine the code is working. Oh, it works in my system. It works in system because of this Docker technology. It successfully runs in each and every environment. See, that's the reason, guys, what happened, right? When you are developing any application in the Docker containers through the Docker technology, right? The same application you can easily port even into your cloud technology also, right? Suppose you say that Rajesh, I'm having an e-commerce application which is running in my VM, in my machine where I have installed Docker, and my application is running in a container. Can I deploy, or can I migrate my whole application from my on premises to the cloud? Yes, you can do it actually. It is very, very simple. It is very easy. right? So because like this Docker, right, it actually it supports in almost all the environments, and it works even in the cloud environment also. So that's the reason most of the industries, right, they are implementing all their application through this Docker itself, because like they can actually migrate your the application from the on premises tomorrow to the cloud, because it depends upon the client. If the customer says that your application has to be hosted in some cloud environment, so I need the service to the cloud, means yes, the company has to give the service for them, so they can easily migrate this application from the on-premise to the cloud actually, right? Okay, now what is required actually? So earlier, that's why I said that. So I missed one point actually, to deploy the application in all these uh, different, or on all these environments, or all these different environments, right? We need to take care of installing the um, softwares required to run the application in all these environments. So hence the DevOps engineer and the DevOps engineer faces uh, difficult faces the challenge to uh, hence the DevOps engineer faces, or you can say that's not hence the DevOps. So basically, I can just say simple. So it is a difficult task. So it's a difficult task for the DevOps engineer. Right. That's the reason what happened, right? There is a shift from this to the Docker technologies actually. Okay. So what is a Docker is not, but it is nothing but it is nothing but a platform for packaging, deploying, and running application. We say, even if you go to the official website, right? Like the Docker, if you go to the official website of the Docker, like what is Docker? Like if you type it actually, he says that Docker is a set of platform as a service product the US that uses OS level virtualization to deliver the software in a packaging called container. This is very, very important definition actually. Docker is a set of platform as a service product that uses OS level virtualization to deliver the software in package called containers. So the service has both premium as well as a free tier. The software that hosts container is called as a Docker engine. Okay. So this is what the Docker VC is actually. Okay. So now I've already mentioned the virtualization, but let me write the notes. So guys, you need a notes. Naresh, you need a notes for virtualization. What is virtualization? What is containerization?
In starting days, we have no, sir.
Yeah, we have it, but if suppose you want to make it more simpler actually, because this notes will play a very important role, because if you read the notes, it is enough for us,
Okay.
right? So what is virtualization? If they call it, you have to simply say installing multiple, how I can say, uh, installing the multiple guest OS. Huh? Okay, yeah, guest operating system in a one in one host operating system. So that's we call the virtualization. It's a very in a very simple term you have to say like this. In having a multiple guest operating system in a single host operating system, it's called the virtualization. So and the next point, something like hypervisor software. Hypervisor software is used to achieve this. This and what else? Uh, so we need to install the required softwares in the host operating system to run our application. Okay. Uh, we need to install the required software in guest OS to run our application. Okay, then system performance will become very slow in this actually. I already mentioned here as advantage disadvantage, but still I'll write it. System performance will become slow in this process. So to overcome that, we have a containerization. So to overcome with this problem of virtualization, we are going for containerization, containerization concepts actually. So what is a containerization concept actually? Okay, so containerization concept, it is used to package all the softwares and application codes in one container for execution, right? Correct. Containers, how I can say, containers will take care of everything. Actually, you need not to worry. Earlier, what the DevOps needs to do is to worry about a lot of installing all these softwares. So you say that, okay, Rajesh, I want to, whenever I want to deploy this application which is there in the Git repo, right? First, I need to have all the software deployed actually, or all the software installed in this machine. Let it be in dev environment, let it be SIT, right? He need to develop, he need to install this. He need to have an operating system like Linux, Red Hat or CentOS or Ubuntu. He need to install the Java 1.8, Spring Boot, MySQL, many other software. He has to install it as well as that some of the dependency library also. He has to install it actually. Now what happened, right? Those days are gone now. So what happened, right? The DevOps for the DevOps engineer with the help of this container, right? It has made his life easy now actually. So containers will take care of everything which is required. It is required for it is required to run our application, right? That's what we can run the container. We can run the container in multiple environment or in multiple machines easily. We can run it actually. So Docker is a how we can run because of the Docker. Docker is a containerization software developed by developed by really developed by Docker Inc. company. Docker Inc. is a software company who developed this Docker actually. So using Docker, we will create our containers for our application. But how to do that and everything, as I said, like we need to first write a Docker file, and through the help of a Docker file, you need to create a Docker image, and finally you can run a container. This is what we will be learning later. And I mean, all these things have been covered in my previous playlist. But I'm just saying that how exactly a developer will do, because the developer has to write a Docker file first actually. So in the Docker file, he will be mentioning all the things. Like for example, you say that Rajesh, I want to install the Apache, right? Apache install. How you do that in if you go to the machine, suppose you take a VM and you say that Rajesh, I want to install the Apache. What you'll do, you'll just say sudo apt update. First you'll say sudo apt update -y. I'm just talking about in Ubuntu, and you'll say sudo apt get install Apache 2. Like this you say, right? This is how you install the software. Same thing how you do in a Docker means you need to create a Docker file like this. So there you have to say from Ubuntu 18.04 or 20.04, like then you'll say run apt get update and apt get install what is it, install Apache 2 -y, right? And then he uses something like expose 8080, and then he uses some cmd command, cmd, or he uses some kind of a entry point. See, we use so many commands. These are all internal commands of the Docker itself, actually. So this is how what happened, right? Uh, the DevOps engineer or else the developer, right? They will write a Docker file. With this help of the Docker file, what happened, right? Finally, he will create an image actually. How to create an image? We'll come across with that command, Docker build. He will use a command by name Docker build -t, right? That and the image name, right? Like this, we will use this commands and all to create a Docker image, and finally we will run that Docker image actually. How to run a Docker image? You know that command Docker run or Docker run and specify the image name actually like this. I hope guys you are recalling all these things, whatever we had discussed, right? So this is how what happened. The developer will do it actually. So using Docker, we will create our container for application, right? How Docker file with this actually. Then what happened, right? Docker images. So once we do it, what we can see, we are doing all the things to just to create a Docker image. But what we can do, we can have a Docker image, and we can easily share this image, or we can easily we can share easily to multiple servers, right? Or to a multiple machine, right? It is very easy, right? Once you have an image, you need to just copy this image to multiple different servers or multiple different machine and just run a container. That's just run this image. Once you run this image, what happens? Docker will create a container for that image. So once the container is getting created, it means that your application will start running within that container actually. All right. So using the image, what we say that using a Docker image, we can we can create a Docker container. That's what I was saying, and we can execute it. That's all, right? So if I just want to show it in a pictorial diagram about this, so this will be like something like this. Let me use some orange color. So this is nothing but your application with the Docker, we say. So once you develop an application with the Docker, so basically what happened, right? You will create a Docker image actually like this. Docker image will get created like this. So you will create a Docker image like this. So once you create a Docker image, what happened, right? You'll be having a multiple servers like this, multiple machines, we say, right? Like for example, this is nothing but your machine one, this is machine two, right? Machine two. So this is not but your machine three, right? So with the help of this Docker image, what you can do that you can actually create a container actually in this machine. You can actually create a Docker container. It means that you can run your application within your machine with the help of a container technology like this. Same thing here also, same stuff like this. Same Docker container, the same application with the help of Docker container, you can run in a multiple machine. That's what it is very easy. That's what I'm saying that you can share this Docker image to the multiple machines. The machine, this machine might be Linux, this might be Windows, this might be Mac. It could be anything, any operating system it could be. But you can comfortably run the container, or you can run that application with help of a Docker container. Okay, guys. So what is the conclusion finally? After this, I know that there are some of the things which are being repeated most of the time, but it is good that we just add a quick no recap of whatever we learned, right? So Docker is a container software. This is very clear now. So Docker is a containerization software. Docker takes care of the applications and application dependencies for execution. This is what finally we have to conclude it, right? And what else? Deployment, deployment of, deployment of, or deployment uh, in multiple environment will become very easy if we are using Docker actually. Right, guys? Okay. Now, okay, it's already been 1.5 hours, so I thought I will cover few of the things. Okay. So this is what like today we just had a quick start on what is a Docker, right? We know all these things, but just I reiterated some of the things which we had covered in our previous playlist, right? So what would be doing? What is our next agenda? So in the day two of the advanced Docker, so what I'll be covering like what are the different installation, how to install installation of Docker. Like you can install the Docker in Ubuntu, or you can even install the Docker in CentOS, or you can even install the Docker in Amazon Linux. Anywhere you can install it. You need you need a machine actually, right? And then like you will be getting into some more in detail about like how exactly the Docker works internally, how Docker works, how Docker works internally, like this is what we had missed in our previous playlist. So we didn't cover like how exactly internally Docker works actually. So see, it is not really required for any Docker engine. Suppose you're working in a Docker, you know how to do a how to write a Docker pull, sorry, how to write a Docker file, how to do a code pull, code push, you know all the commands. It is not really mandatory that you should know all these things, but it is better that sometime what happened in interview, they might ask how exactly internet Docker works actually. They might ask you what is a Docker container D, how the Docker came into existence, right? So some history about the Docker actually. So you need to even learn about some history behind the Docker installation. And of course, like we will be getting inside in detail about many of the Docker after installing the Docker, and after learning how Docker internally works, you will get into the Docker commands, a quick go through the Docker commands, and then we will get into some higher concept of Docker actually. Right, that is what we would be starting from the next session. So it would be very interesting, like there are many things which we will be learning in the advanced Docker sessions, right? And I'm hoping that we would be covering some 8 to 10 sessions on advanced Docker. That's what I think. So once the Docker advanced completes, then like we will be getting into the advanced Kubernetes actually. So this is what we will be getting the next. So for the next I think for next minimum, I am just thinking that minimum 3 to 4 months, minimum 3 to 4 months actually, we will be learning the advanced Docker and advanced Kubernetes concepts actually. Of course, Kubernetes, many of the viewers have asked me many of the things, like some of the things which I have left in my previous playlist, right? For example, the last which I covered was the Helm actually, but I couldn't complete it. Just theoretically, I told about the Helm. So then I have to start like after that, like horizontal auto port scaler I have to do it. English load balance I have to do, right? How Kubernetes works in different cloud. What is EKS, AKS, right? So there are what is the Kubernetes dashboards actually, right? How to integrate the Kubernetes with Prometheus and Grafana, and like what are the when it comes to the security part, right? How Kubernetes works there, right? We had even two conversation on the RBAC, right? Role based access control, right? So in the security part, right, I will be going into much more in detail about the RBAC concept. So Kubernetes, what is my plan is that whatever we have in the CKS, right? Certified Kubernetes Security Administrator, right? So certified Kubernetes security, right? That is one of the like uh, one of the certification which we will do it actually. So based on the CK's content, whatever the CK's has, right, I would be covering in my advanced topic actually, in advanced communities. That's what I am just planning. Okay. So those things and all I'll be covering. So the next 3 to 4 months, right, we will be heavily learning about both these tools, Docker and Kubernetes. So once that completes, right, I will be taking up on AWS or Jenkins, anything, right? So guys, that's what for the day today, right? Uh, anything, sir? Any doubts, Mahesh and Naresh? Naresh or Mahesh? Mahesh, sir.
No, Rajesh.
So how it was like this was a quick recap of something, right? Maybe we might have recalled some of the things, right?
Yes, Rajesh.
Yeah. So that's what we'll be learning in the next session. We will be learning even about the Kubernetes architecture also, sir. I forget to mention that. So history behind how Docker works and Docker architecture, not Kubernetes, Docker architecture. We'll be learning even that also. Anyhow, we know this because in my previous playlist also had showed about that. What is a Docker hub and all, right? Those things and all. What is Docker registry and all, right? And what is a Docker client? What is a Docker host? What is a Docker daemon? Right? So same thing we would be covering here also in the next session. But those are all something like a quick recap of everything. After this quick recap completes, right? Then I'll switch into the Docker advanced topic. That's what my intention. Maybe you might see some here and there up to one or two session, up to third session, we might see some basic things only we'll be covering. So after the third session, right? Hopefully from the fourth session or from the third session itself, we'll get inside the advanced topic of Docker actually. Okay.
Okay.
Okay, sir. Chalo then, thank you. We'll stop it and next session we'll take in the next Saturday. Hmm?
Sure, Rajesh.
Bye bye. Thank you, sir. Thank you all. Bye.
Bye.
I think we can't stop it. Okay. Thank you. Bye.